Hi geometry students. I'm doing a short video today for us to review chapter 9 before you take a little quiz. Chapter 9 we actually began when we were together in school, and we started with just a basic description of a right triangle and Pythagorean theorem, which, as you know, is a squared plus b squared equals c squared, where a and b are the legs of the right triangle and c is the hypotenuse. The hypotenuse is always the longest side, and it's always across from the right angle. The legs are the two sides that are adjacent to the right angle. It doesn't matter which way you label them, A, B, but basically the two shorter sides are always going to be A and B when you plug into the Pythagorean theorem, and the longest side will always be C. So you can actually use the Pythagorean theorem in a couple of ways. You can use it to find a missing side of the triangle. If you know two of the sides, you can plug them in and then solve for the third side. Or you can use it to check whether three given measurements form a right triangle. Remember, if it doesn't form a right triangle, there's actually something called the Pythagorean Theorem Inequalities that tell us that you can determine what kind of triangle is formed if it's not a right triangle. So if it is a right triangle, it will make this equation true, that a squared plus b squared equals c squared. However, if you were to have an inequality where plugging in the a and the b results in a value that the hypotenuse squared is less than the sum of the legs squared, then this would actually be an acute triangle. And if the hypotenuse squared comes out to be greater than the sum of the legs squared, you end up with an obtuse triangle. So you can actually use the Pythagorean theorem to either classify a triangle as right, acute, or obtuse, or you can use the Pythagorean theorem to plug numbers in and solve for the third side if you know it's a right triangle. So that was the first section. And remember, there are certain Pythagorean triplets that are just useful to know because Pythagorean triplets satisfy the Pythagorean theorem, therefore they are definitely going to be a right triangle. The most common one is 3, 4, 5. And then some that derive off of that are multiples of 3, 4, and 5, like 6, 8, 10, and 9, 12, 15, etc. There's also 5, 12, and 13 is a common one. And multiples of that would work. There's, we had a bunch of those. So sometimes if you recognize at least the basic ones, you can save yourself the time of not having to go and plug into Pythagorean theorem to solve things. This was the first section that we covered. Okay, let's move on to talk about the next section, which was the first thing that you did on your own for virtual learning, special right triangles. If a right triangle has two legs that are equal, so it's isosceles, then you have what's called a 45, 45, 90 triangle. Remember that? Yeah, it's been a while. But don't forget that there was a special shorthand that you could use so you don't even have to plug into Pythagorean theorem. If you know that something has 45, 45, 90, right? This is the 45, 45, 90 triangle, then the sides have a special relationship. We would call both of the legs n, and then to find the hypotenuse, it would just be the length of the leg times radical 2. So, for example, if you had a 45, 45, 90 triangle where each of the legs was 3, then the length of the hypotenuse, you don't have to plug it into the Pythagorean theorem. You can just know that the length of the hypotenuse is 3 radical 2. The tricky kind of equation is if they give you the hypotenuse and ask you what the leg is, and you recognize it's a 45, 45, 90, so you decide to use this relationship. And basically, to go from hypotenuse back to leg, all you need to do is divide by radical 2. So let's say you were given a 45, 45, 90, where the hypotenuse is 5 radical 2. Then you were asked, what is the length of each leg? And you'd say, well, 5 is just in the place of n there. So all I have to do is drop the radical 2 or divide by radical 2, and I'm left with n. So each of these legs would be 5. Now, if it doesn't have 5 radical 2, that format for a hypotenuse, you still just do division by radical 2 to get the leg. It just wouldn't be as obvious without maybe doing a little bit of radical arithmetic. Anyway, that's 45, 45, 90. The other kind of special right triangle was a 30, 60, 90. Okay, remember this one? There was another special set of relationship among the legs. The short leg we were going to call n, and that's kind of our reference for all the rest of the triangle. In order to find the hypotenuse in this kind of triangle, you just take the short leg and multiply by 2. It's just double. And then in order to find the, my son wants to get involved in this video. Hold on. Okay, he ran away. So in order to find the long leg of the 30, 60, 90 triangle, you take the short leg times radical 3. So this is the relationship. N for the short leg, 2n for the hypotenuse, n radical 3 for the long leg. Now to go between them, like say you know the hypotenuse, if you want to get back to the short leg, you just divide by 2. If you know the long leg and you want to get back to the short leg, you have to divide by radical 3 to get n by itself. If you know the long leg and you want to get to the hypotenuse, you kind of want to go around this way. First divide by radical 3 to find the short leg, then double that to get the hypotenuse. Okay, so I'm doing this video so maybe you could take some notes, and then when you take this little quiz, you can refer to them, and hopefully that will be helpful to kind of just review everything before you get started. Okay. And then really the last topic in this chapter that we decided to cover, I did skip 9.3. I don't know if you're following along at all in the textbook, but we did not do geometric mean and special similarity of triangles in 9.3. So don't worry about that for now. There's just certain things we're not going to get to this year. And that's okay. This is a different kind of year. Anyway, the last topic was trigonometry, which we summarized with this nice little mnemonic device, SOHCAHTOA, SOHCAHTOA. And it stands for the sine of an angle. In Khan Academy, they use theta, so I'll just put that here. Sine of an angle is equal to opposite over hypotenuse. And cosine of an angle is equal to the ratio of the adjacent side over the hypotenuse compared to that angle. And tan of an angle is equal to opposite side over adjacent side. So we have the highlighted letters here, SOH, CAH, SOHCAHTOA, TOA. Okay. And these trig ratios apply to all right triangles. Yes, they even apply to special right triangles, but the special right triangles, we memorize certain relationships because that should save us time if we know those certain relationships. So trigonometry is based on the fact that it's a right triangle. We always call the right angle C because across the way, the hypotenuse would be C, and in the Pythagorean theorem, that's just a tradition that a squared plus b squared equals c squared. C is the hypotenuse. So if I put A up here and B down there, A, B, C, then I would call this side lowercase a and this side lowercase b, whatever's opposite. These are the acute angles that could be the subject of the trig functions. You could be putting a number in here in for that angle, right? Or you could put this number in for that angle. It all depends on which part of the triangle you know and which part of the triangle you are trying to find. And we talked about solving right triangles, given certain information, solve for another part. So let's just say that I had, for example, let's just say that the value of B was given as 9. And in order to make this work out correctly, I'm going to take a second to figure out what I want there in A. Okay, for this example, I'm just going to say, let's say that we were given that side B is 9 and side C is 18. What if we were asked to solve for angle B? Well, using trigonometry, I would say, all right, let me see. I'm focusing on angle B. Angle B. What parts do I know or care about of this triangle in relationship to B? So in relationship to B, I know the side that is not connected to angle B. It's all the way over here across the way. It's opposite of angle B. So I've got the opposite side given to me. And then when I look at C, oh yeah, that's the hypotenuse. It's across from the right angle. So I'm going to label that hypotenuse. And I really think when you're first learning trigonometry, great idea to actually label your parts with what they represent in relationship to whatever angle you're focusing on. So if we want to find angle B, we are going to say, okay, what trig function puts together opposite and hypotenuse? And that would be sine. So I'm going to set up the equation sine of angle B equals opposite 9 over hypotenuse 18. Now, I'm looking to find an angle here, and right now it is kind of embedded in this sine function. So how do I get it out of the sine function? What do I do to undo sine? Do I subtract sine from both sides? No, not really. We actually apply, as you remember from a previous lesson, we're going to apply the inverse sine to get rid of sine from around B. We're going to do sine -1. This is also called arc sine or inverse sine. And whatever you do on one side of the equation, you have to do on the other side the same. So I'm going to do inverse sine of 9 over 18. Over on this side, this just leaves B isolated by itself. And on that side, I have a calculator problem to plug in. I'm just going to calculate the sine of, sorry, not the sine. I'm going to calculate the inverse sine. See how it says sine to the -1? Of 9 over 18. 9 divided by 18. Close the parentheses. Press enter. Whoops, I opened the parentheses. Close the parentheses. Press enter. I got 30. B equals 30 degrees. Well, what do you know? It's a 30-degree angle. Hey, did you notice that the hypotenuse was twice as long as the short leg? This is a 30, 60, 90 triangle. Had I noticed that, I could have just said it was 30, but this proves that even the special right triangles obey the trigonometry rules. Okay, so The inverse sign cancels out the regular sign to get the measure of an angle. If the measure of an angle is the thing you are looking for, you're going to end up using the inverse trig function, not the regular trig function. Okay, I just put one more problem up for us to review. Here we have a fresh right triangle, and the given information is that the measure of angle A is 12 degrees. Now, this doesn't look like a 12-degree angle by any means. It would be much skinnier than that if it was actually 12 degrees drawn out. So you could picture it being a lot thinner of a triangle. But then they're telling us that side B is 16, lowercase b is 16, so that goes there. And we want to find the hypotenuse of the triangle. So in this case, again, we're going to focus on the angle we have and what we know and what we care about and identify those parts. So this side is not across the triangle, it is attached to the angle. It is the adjacent side. This part, C, is always the hypotenuse. So when adjacent and hypotenuse are both together in the same arena here for this problem, compared to that angle, what are we going to use? Adjacent hypotenuse, cosine. So let's set it up. The cosine of the angle, I'll just write it out once like this. Cosine of A equals adjacent over hypotenuse. And then I'll actually plug in the numbers. The cosine of 12 degrees equals 16 over hypotenuse, C, that I'm trying to find. So here's my equation. Cosine of 12 equals 16 over C. C is in the bottom of the fraction. I've said this before, and I'm just going to show you one more time. You could treat this like a fraction itself with a 1 on the bottom, and you can basically swap out these two cross products. You can just switch the order of them. That's a shortcut that works algebraically, or you could multiply both sides by C and then divide both sides by cosine of 12. Either way, the result will be C by itself over here equals 16 over cosine of 12 degrees. And so just do that on the calculator. This is regular cosine, not inverse cosine. It doesn't have the little -1 because we actually have the angle. We're looking for a side. So 16 divided by cosine of 12 should look like this on the screen. 16 divided by cosine of 12 equals 16.36. About 16.4. And so that would be the hypotenuse value. So I've gone through one of each type of problem pretty much, including a trig problem where you're looking for the angle and a trig problem where you're looking for a missing side. And remember, if you had to solve an entire triangle, you could start with just finding one of those things. Once you know one acute angle, you can just subtract from 90 to find the other acute angle. So that helps you solve for the other angle without having to do more trigonometry. Once you know two of the sides, you don't have to do more trigonometry to find the third side. You could just use Pythagorean Theorem back up to the beginning of the chapter. So you can solve the entire triangle starting out with trig and then relying on some earlier, simpler tactics. Okay, I hope this has been helpful, and do your best on the little big ideas quiz for this chapter. It's kind of a quest, small test, big quiz, and I hope to see some good work there. And I wish you a wonderful spring break. Take a break, enjoy yourself, do things that you like, stay healthy, and hopefully I'll see you soon. Bye.